What do scientists really know? When and how do they know they know? What are their certainties, but also and above all, their uncertainties, their questions, their doubts? What do they do with them? Hello, I am Anne Laure Gannac. I'm a journalist at the Humanities College of the Ecole Polytechnique Federale de Lausanne, and you are listening to a podcast. Are you sure? Yes, you are listening to a podcast. Are you sure is its title? And this is a question that will guide me to meet the people who do science at EPFL, to take the pulse of their certainties and uncertainties.
Hi, my name is Wendy Queen, and I was born in South Carolina in the US. I received my PhD in chemistry from Clemson University, also in South Carolina. After that, I did a postdoc at the NIST Center for Neutron Research, just outside of Washington, D.C. And then I took a position at Lawrence Berkeley National Lab, where I was a project scientist. After that, I received an offer from EPFL to come and join the institution here as an assistant or a tenure track assistant professor in chemistry and chemical engineering. So I moved to Switzerland about 5 years ago with 2 big dogs and a cat.
Hi, Wendy Queen. Thanks for being with us today. First, could you tell us a little bit more about what you are doing in your laboratory?
So I have a research team here at EPFL that is focused on the design of porous materials. And so the best way I can describe these materials is essentially we make fancy sponges. And so the key is that the size of the holes in these materials is about 50,000 times smaller than the diameter of a human hair. And so what we really do with our sponges as chemists is we go inside and we decorate the insides of these sponges in special ways. So we put special functionality inside that can actually allow us to extract important contaminants, so highly toxic contaminants from water. We can also selectively grab certain species, various molecules like carbon dioxide from air or other gas streams. And so this is what we're basically using these sponges for, is to extract selectively certain contaminants from gas and liquids.
Why did you choose this scientific career? How does it resonate with the childhood you had?
Basically, when I was a kid, actually, I never wanted to be a scientist. I always wanted to be a professional baseball player. And so when I was 5 years old, I learned to play baseball, and I lived in a very rural part of South Carolina, the foothills of the Blue Ridge Mountains. So I spent most of my time when I was not in school outside, climbing trees, learning to play sports, fishing, things of that sort. So I just always had a really strong connectivity with my environment and nature and things like that growing up. So I think that influenced my career choice, but also so as I grew up and I became more educated, I realized that some of the things that I took for granted, for instance, like clean air and clean water, that many people in the world didn't have access to these things. And so essentially I decided that I would try to use chemistry to help these things, because I feel like these are access to clean air and clean water should be a basic human right, not a birthright. I started working in research to help to try to overcome these issues. And I would tell you that I was probably in my second year of college when I really decided that I wanted to pursue chemistry in general. And so at that point, I realized that I could use my ideas and skill set to help solve important problems in the world.
Do you remember if there was one event that made you say, okay, this is what I really want to do for sure?
I would tell you that I was never extremely sure. So I would, my second year in college, I was really pressured to choose a major. And so it was really between chemistry and chemical engineering. And the reason for that is because I wanted to have a career that challenged me. And of course, these topics were challenging for me in school. And I knew that if I pursued these topics, that I would have a job in the end where every day would be different and exciting, so to speak. I didn't want to do the same things day in and day out. And, I also have always liked to apply the knowledge that I have solving problems. And so, because of these things, I think chemistry was an obvious choice for me. Research didn't become an obvious choice until, I'll tell you, my last year in college. And I was actually doing a very small research project. I went to a very small liberal arts college in South Carolina. And I was in the lab one day working on my research project in the summer. And one of my advisors walked in and he sat down and he said, "Wendy, where are you going to graduate school?" And I said, "I'm not really cut out for graduate school, I don't think. I'd come from a family that didn't have any college education or anything. And so I was just happy basically to be at the university. So I wasn't really looking beyond the university." So this professor asked me what I intended to do in the future. I told him I was just going to go out and get a job. So he jumps up and he runs into his office and he prints out an application and he brings it into me. And he said, "Listen," he said, "if I did well in graduate school, you're going to be amazing." And he said, "By next week, you should have filled this application out." And so I would tell you that really his encouragement is the reason that I actually made the choice to look at research and then in the end actually pursue a career in research.
So it means that basically you needed others to help you be sure.
Absolutely. I mean, our perspectives are limited by the things that are around us. And so, like I said, coming from a family, most of my family actually worked in a local textile mill. I think I'm the only one in my immediate family that didn't. And so they didn't have college degrees and things. So for me, I had a very limited perspective on even the universities and things that I attended. I had no help in applying for scholarships and things. As I told you, I love baseball, and so I actually used my skills in that to actually pay for my college education with some scholarships and things. But had it not been for encouragement from people around me, I probably would not have known how to pursue those things and realize the importance of getting an education, right? And so I wasn't applying to top institutions. I never had any perspective about these things. And so for sure, I'll tell you that my mentors, the people who've given me encouragement and kind of helped open doors for me, have been extremely important in my case.
Both baseball and science are very masculine universes. Is it a coincidence, or is there any reason why you would have chosen these masculine fields?
Possibly. I had two older brothers and two cousins that lived next door, all male. My father was around quite a lot, and my uncle, so I spent most of my time with them. My mom worked quite a lot, and so she wasn't around as much. So I had a very strong male influence in my life, and I think they encouraged me to do the same things that they were doing, right? So maybe I had a little bit of a different upbringing than some. In fact, I played all male baseball teams until I was 12. I even played American football on an all male team when I was little. And then when I got a little bit older, I did switch to fast pitch softball because it's a predominantly women's sport, and so I could play that all throughout college. But even in Switzerland, I still play baseball, and it's mostly men's team. So I don't know if growing up in an almost all male environment had some influence in that, but it's possible.
Wendy Queen, you started this work thinking that it could join your ideals. Do you still think today that science can change the world?
That's a good question. I do think that science can make an important contribution to helping to change the world. I mean, this is where very specific solutions come from for problems, right? But we have to consider that science is not the end all solution for everything because For a lot of science to be implemented, it requires policy, right, and policy change, because not all scientific solutions come without a price tag. And so I would tell you that science, in addition to policy, is very important for implementing various scientific solutions. Also, education is important because scientists alone can't change the world. The general public also has to be educated so that we begin to make better choices, for instance. We know the impact and the footprint that we have when, for instance, we're flying around the world or we're buying loads of plastic products and things of that sort. And so I think that science is an extremely important part of the solution, but I think it's not the only solution. Education, policy, things of that sort also play a strong role.
Do you often doubt the usefulness of what you are doing?
In general, science is very uncertain. So I'll tell you that as a scientist, you have to be good at failure. Probably 90% of what we do is fail. And even when you have great successes that you're super proud of, particularly if you're working in a field where you're trying to solve very large scale problems, it's really difficult from a lab setting to know how those problems are going to be implemented in the world and how those materials that you're developing are going to be implemented in the world and perform on much larger scales than, for instance, what you're testing in the lab. So I would tell you that maybe that is a little bit of where the uncertainty comes in, because like I said before, we're always limited by our perspectives, and if you don't have these perspectives, then it makes it difficult to know exactly how things are going to evolve, so to speak, in the end.
So there are a lot of uncertainties, but can you access any certainties?
I try to avoid absolute certainties because I think that these things are dangerous. If you're very certain about the world, then you don't necessarily question it. You don't question the things around you. So the things that I'm relatively sure about, I know that our environment is changing. It's changing in negative ways. And I believe that we have to make strong efforts in order to change those things. I'm pretty sure that there are multiple solutions to those problems. There's not just one single solution. And so I believe that we need to explore many different areas of science and things to overcome these issues that we're faced with.
How has your relationship to science evolved since the start of your scientific career? Would you say that you are more certain or more in doubt?
I think that I've become more confident. So I'm much more confident because I have a lot more knowledge now than I had before. I wouldn't say that I'm absolutely certain because science makes you question certainty every day, because you go to do an experiment and you typically get some unexpected outcome, and that tells you that you have a lack of knowledge in this area about the underlying mechanism of how things function, right?
Right. What do you think of the place and the role that scientists should play in our societies today?
I think that scientists should evolve a bit, kind of go away from the traditional perspective of a scientist being just in the lab and just doing experiments, because I think scientists have a lot more to offer to the world. As I mentioned, in order to make change, we need science solutions, we need policy, and we need education. And I think that scientists can play an important role in all of these areas. I think that with science communication, kind of what we're doing right now, we can help the general public as well as the policymakers understand what we believe the problems are and help them understand the solutions to those problems. It's also important that we're helping to educate the general public. I mean, I'm a professor. I spend much of my time teaching, right? I think I have an important role to play in terms of educating the general public and helping them understand what the problems are and potential solutions to those problems.
Going back to ecological issues that you're working with, science is also part of the problem. So how do you deal with that, Wendy Queen?
Knowledge is very powerful, and this is really where science comes into play. You make a very important statement, and that is, for instance, we've been producing energy using fossil fuels, and maybe until recently, people didn't realize how impactful these things would be, for instance, on our planet. And Um, I think that with knowledge we gain more awareness. And so understanding our environment more is extremely important, and understanding how our scientific solutions can potentially impact our environment is important. But it's not always easy from a lab to know how these things will impact an environment, for instance. And so I think that because of that, scientific solutions need to be really multi-scale. People need to work together that have various backgrounds, for instance, to understand how a new materials application, how's it going to impact our world economically and environmentally. For instance, what is the CO2 footprint? How much water will these processes consume, and things of that sort. And so these are really multi-scale problems, and I think that you need a pool of people with expertise in different areas to be sure that scientific solutions are indeed ecologically friendly, so to speak.
And is it what is going on right now? Do you think that science goes enough in that direction?
I don't think it works enough in this direction. I mean, as a scientist, when we develop a new technology, it's not necessarily easy to access an understanding of, CO2 footprints and things like that, what we would call like a life cycle analysis, so to speak. But I think it's moving more and more in that direction. And so with new programs and funding mechanisms so that you can bring lots of people together with different expertise to solve a specific problem, this can be an extremely powerful approach.
Wendy Queen, you said that 90% of what you were doing was failing. How do you recognize that you have succeeded?
Even failure is success. And I know that that sounds a bit weird, but actually failure is one of the most instructive things that you can do, because you learn from that. You learn a lot from failure. When we know that we've really succeeded, typically, for instance, I mean, my group is very applied, so we're designing materials for very specific problems. And so if we design a material and we test it in the lab and we see that that material is outperforming existing materials, then of course we get extremely excited about this sort of advancement, because we then know that our material has the potential to make a large impact. But like I said, my group is very applied. You also have science that we do that is much more fundamental, and maybe the knowledge that we gain can't yet be applied to solving a large scale problem. However, it's still extremely exciting because we understand something new about a system that we never knew before. And so in the future, as this knowledge accumulates, we get more educated and we make more clear, quick advancements.
Do you feel any pressure as a fundamental researcher to give applications to what you are doing?
I don't necessarily think that. I think that there are a lot of different types of funding schemes. And so you can apply for funding schemes that might be more applied, or you can apply for funding schemes that are more fundamental. There is appreciation from both sides. However, when you ask about pressure, this job is definitely full of pressure, because whatever you do, whatever that may be, whether it be fundamental science or applied science, you have to do it extremely well. And you can imagine that in some fields it's extremely competitive. Depending on the institution that you're at, if it's a top ranked institution, that pressure increases. We're expected to bring in funding to fuel the research that we're doing, and that consumes a lot of your time. So if you want to have a large team, you have to have a lot of money. And so I spend a huge portion of my time doing these things, and oftentimes then we're out in the public giving presentations, we're traveling around the world giving seminars, and in addition to doing research and teaching and lots of other things. And so it's a job that is, you find yourself doing a lot of different things. And so that can increase the pressure, because you're constantly trying to manage everything and figure out how best to manage your time to be the most impactful as possible.
In the end, Wendy Queen, what makes you sure that you did the right choice and that you shouldn't have become, well, a professional baseball player?
Baseball is something that I love, but I can't make a strong impact in the world doing that. And regardless of whether, the materials that we're making in the lab can go out and change the world, I mean, I hope that we're trying to push towards that. But also, I'll tell you that one of the most impactful things that I do is training young students. And in fact, these young students are hungry, they're super motivated, they want to make positive changes in the world, and it's more gratifying for me to see them go out and be successful, I think, than anything. And so because we're training so many students that are going out around the world, it actually significantly increases our impact, so to speak, if you think about it in that sense. Because we're training the next generation of scientists that are hopefully going to do really amazing things.
Thank you very much.
You're very welcome. Thank you for having me.
It was Wendy Queen, tenure track assistant professor at the Laboratory of Functional Inorganic Materials at EPFL. And you know what? There are other episodes of your podcast, Are You Sure, that are coming right after this one.